Good morning, students. Welcome to Fluid Mechanics 2 video session. So yesterday we are discussing about the priming. That is what we are discussing about the topic called centrifugal pump. In that one, yesterday we discussed about the priming for centrifugal pump, and also we discussed about the work done by the what we can call the pump or impeller on fluid. So today we'll continue with the same topic, and that we are going to discuss about the different heads of pumps, and also we are going to discuss the efficiency of the pump. Okay, so it will take another two maximum three classes to complete this particular chapter. After that, we'll move on to the sixth unit. Okay, that is very gradually varied flow. Fifth unit, you can study yourself. Okay, it is a theoretical topic. So, okay, in detail, I will let you know through WhatsApp. Okay. Okay, let's concentrate on this particular topic, that is head of pump. See, there are different heads are there. जैसे मैंने कल already हमने discuss किया था, like section head is there, delivery head is there, like that. Only we discussed about only two type of heads, right? So let's see different classification of heads in the centrifugal pump. So first one is static head, that is we can call it as the H suffix S. Okay. The second one is monometric head. Okay. That is H suffix M. These are the two heads. Okay. Within that one, there are different types of heads are there. So let's start. Let's discuss the these two heads. That is static head and monometric head. See, the first one is, see, this particular diagram is most important diagram because you can see a lot of explanation. I'm using the same diagram. Okay. Okay. Static head. The sum of the suction head and the delivery head is known as static head. So that means if you take, this is the sum, correct, from where you need to lift the water, and this is the overhead water tank where you need to transport the water, right? So if you see this particular diagram, this is casing and this is inside. This is called as impeller, and this is the suction pipe and this is the delivery pipe, right? These are the four important parts which we discussed in the previous class. So what happens is once the motor is on, that electrical energy was, see, working, फिर से समझा रहा हूँ ताकि एवरी क्लास में आपको बेसिक कॉन्सेप्ट समझ में रहे कि पंप कैसे वर्क होता है, सेंट्रीफ्यूगल पंप. Then based on that one only, there are so many other criteria or so many other points comes into picture. So once you switch on the motor, or what happens is that because of that electrical energy, it rotates the shaft, right? The shaft will be connected like this, and when shaft starts rotating, so that means your electrical energy is converted to mechanical energy, right? So once the shaft rotates, obviously the impeller is placed or mounted on the shaft. Because of that one, even the impeller starts rotating. Okay. So once the impeller starts rotating, like because of with high velocity, so what happens is the center portion of the what we can say the high of the impeller, so creates a negative pressure. Because see, before it was it's air will be there. Okay. So as this particular impeller starts rotating, obviously the air starts rotating. Okay. जैसे it starts rotating with the impeller, the centrifugal force will be created, and that centrifugal force is nothing but the force that is it pushes the air away from the center. So once the air goes away from the center, in center of the impeller, that is, it is called as eye of the impeller, there is a suction or negative pressure is going to create. That is nothing but the suction pressure. So that suction pressure sucks the water from the your water sump or something. Okay. So that water comes into the radially enters into the impeller, and the concept continues in the same way. That is, the once the water reaches here, uh, the water also starts rotating, and obviously centrifugal force will be created, and it pushes the water away, and that water goes like this. And obviously you can see the area is keeps on increasing. Because of that one, the pressure builds, and that pressured, whatever the liquid is there or water is there, it is going to lift here, and it is going to reach the overhead tank or whatever the destination location is. Okay? Or destination tank is there. So this is how the your centrifugal pump works. So now, why I told all these things means, if someone has missed previous class, this is how the working of this thing, centrifugal pump. So now what is the your head, that is from the what we can say free surface of the sump to the central line of the shaft, or we can call it as the level of the eye of the impeller. So this distance or this head is called as suction head. That is, we can call it as h suffix s. I written here, it is overlap. Okay. Similarly, if you take okay, this is suction head. Okay. Similarly, from the level of the high to the wherever the delivery has to be done, that vertical height is nothing but the delivery height. So if you add these two things, you will get the static head. H suffix s, that is static head from level of the water surface at the initial or inlet to the eye of the impeller level. Either भी लिखा है देखो. So section head is equal to small hs plus small hd. So what is the static head? Sorry, ठीक है. Section head बोले तो क्या है? It is the vertical height of the central line of the pump shaft. This one. This is the shaft where it will be. So this is the central line of the height, vertical height of the central line of the pump. This one above the liquid surface. This is the liquid surface. This vertical distance is nothing but section head. Similarly, delivery height is nothing but it is the vertical height between the center line of the pump. So this is the center line of the pump to the of the pump shaft and water surface of the delivery tank. So obviously water surface of the delivery tank. तो ये वेरी हो सकता है. ठीक है, ये फुल फिल किया तो इधर तक आएगा, तो इसलिए इधर तक भी. So this is delivery head. So both this section head plus delivery head gives you the total, that is static head, not total head, static head. ठीक है. Okay. So now this is what I did. Next one is monometric head. That is H suffix M. See, the head against which centrifugal pump has to work is known as the monometric head. See, basically what happens is, obviously there are two heads are there. This is section head is there, there is a delivery head is there. But when the water sucks from here, it travels to the eye of the impeller, from there to impeller vanes, from there to this casing, from here to delivery pipe, then it will shift and it will travel and it will finally reaches the overhead tank. This is actually what happens. In this journey, so obviously there are some losses are there. Okay? Maybe frictional losses are there, maybe mechanical losses, or any losses will be there. So against all these things, the centrifugal pump has to work against all these losses, and it has to take the water from here to this location. So that is nothing but called as that whatever the to reach or to make the water to reach from this location to this location, whatever that against head is there, or against whatever the energy it required. So that head against which all these things it has to travel is called as the monometric head. So that means it is the head which is required, like total head minus losses. Okay? So here in this particular case, na, you are just telling it is some difference क्या है monometric head और static head में. बोले तो static head में just आप ले रहे हो कि suction head और delivery head. You are not considering any other type of heads. See, this is the additional heads. Correct? It has to overcome all these things. Minus losses भी है. तो obviously अगर आपने section head इतना समझो 2 और ये 2 4 हो गया समझो, तो आप ऐसे नहीं बोल सकते ना, क्योंकि लॉसेस भी है, तो यू नीड टू माइनस लॉसेस को भी माइनस करके जो रिक्वायर्ड है उसको बोलते हैं हम मोनोमेट्रिक हेड. ठीक है. सो इट इज द हेड मेजर्ड अक्रॉस द पंप इनलेट एंड आउटलेट फ्लैंजेस. So obviously inlet to outlet flanges का it can be computed by using expression. So one second. So whatever this monometric head is there, it can be calculated by using the expression, three types expression there. मतलब three way you can calculate or you can find out the monometric heads. Like first one HM is nothing but head imparted by the impeller to the liquid minus loss of head in the pump. As I already told, it is not just head imported or energy imported by the impeller on liquid. It has to overcome the losses also. So that's why you're minusing the loss of head in the pump. So वो losses of head in the pump कहाँ पे होता है? It's mainly happens in the impeller and casing. ठीक है? So this is the first case. That is how you are going to find out the manometric head. That is head imparted by the impeller to the liquid minus loss of head in the pump. So HM is equal to VW2 U2 divided by G. That is head imparted by the impeller to the liquid is VW2 U2 divided by G minus whatever the losses is there. But if you're ignoring the losses, then obviously that manometric head equation becomes VW2 U2 divided by G, which is nothing but the impeller power. So this is nothing but impeller power. No? Head imparted by the impeller to liquid is nothing but the power of the impeller. So manometric head is equal to impeller power if you're ignoring the losses. Okay? The second one, how you're going to find out the manometric head, that is total head at outlet of the pump minus total head at inlet of the pump. So obviously क्या होता है? Now you are measuring the difference between the head, between the outlet and the inlet. So उसमें आपको obviously you are going for समझो if you are applying Bernoulli's equation, ठीक है? At this location Bernoulli's equation and also at this location Bernoulli's equation, ठीक है? That is outlet and inlet के point पे अगर आपने Bernoulli's equation लगा सकते हो. That is total head at outlet pump minus total head at inlet of the pump. So PO divided by rho G, already you know Bernoulli's equation, plus VO square divided by 2G plus ZO. That is O means outlet. This is pressure head, this is velocity head, and this is elevation head. So Bernoulli's equation आपने पहले सीखा. So this Bernoulli's equation at outlet point should be equal to Pi, that is inlet point, divided by rho G plus Vi square divided by 2G plus Zi, that is pressure head at inlet plus velocity head at inlet plus elevation head at inlet. So now you know outlet is nothing but delivery point and inlet is nothing but suction point. So just instead of outlet, I'm writing delivery. That is PD by rho G plus Vd square divided by 2G plus Zd is equal to P suffix x divided by rho G plus Vs whole square divided by 2G plus Zs. ठीक है? So now, समझो if delivery and suction pipe are of same diameter, if these two pipes, that is delivery pipe का suction pipe का diameter and also delivery pipe का भी diameter अगर same है and दोनों at same level पे and at same elevation, sir either इस diagram में same elevation पे नहीं है, correct है? So it is at one location, this is at one location. There is a vertical distance here. But समझो if it is like this, this is the suction pipe है and there is समझो impeller है and this is the one second. And this is the delivery pipe as well. So दोनों का same level. So in this case, ठीक है? One second. Okay. In this case, that means when both the delivery and the suction pipe diameter are same and also both are at the same elevation, so then obviously everything, all these things gone. Velocity will be remain same, correct? Elevation also becomes zero, no difference. So only pressure difference comes into picture. That is the manometric head is equal to PD rho G, PD by rho G minus PS divided by rho G. Okay? Where PS divided by rho G is suction pressure head and will be measured with vacuum gauge and therefore will be added in the above expression. So obviously this, this particular location, that is in suction, whatever the suction pressure head is going to create, it will be measured by using the vacuum gauge. Okay? Because of that, what we call, once the impeller starts rotating, at the eye of the impeller, the suction pressure is going to generate. There is nothing but vacuum will be created. So it sucks the water towards that particular point. So this is the second equation, or second the way you are going to find out the manometric head. This is the third way, okay, where you are going to consider all the heads, losses, everything. जैसे कि manometric head is equal to, you can see there is a suction head, there is a delivery head, there is a friction loss or friction head due to at suction pipe, and friction head at delivery head, and also there is a velocity at what we can say velocity in delivery pipe, PD square by 2G. So if you consider all these things, whatever the values is there, you add it, like losses will be in minus. So you can see HS is section, delivery head, friction losses in section pipe, friction losses in delivery pipe, velocity. Okay, recording हो रहा है. होप कंटिन्यू हुआ है, ठीक है. So what you have to do is, one second. Okay, so that is about the what I can say manometric head, ठीक है. So now that is about the heads in the pump. Now we'll discuss about the losses in the centrifugal pump. So obviously there are different losses will be there, and in the assumptions we consider the loss, whatever the losses is there, it is negligible. So now we are going for we'll study the what are the different types of losses. Okay, the first one is hydraulic losses. The second one is mechanical losses, and the third one is leakage losses, and those are the three different types of losses. Okay, so let's start with the hydraulic losses. Say hydraulic losses, shock or eddy losses at the entrance to and exit from the impeller, and obviously losses due to the friction in the impeller. See, obviously the hydraulic losses in the pump happens in the impeller portion and also at casing. Okay, so because of shocks while the water enters into that particular rotating impeller, there is obviously there is a impact will be there is a shock will be created, or we can call it as a eddy losses will be generated at the entrance and also at the exit of the impeller. So at that particular location, there will be some hydraulic losses will be there. Then losses due to the friction in the impeller. So obviously in that impeller, that is where that impeller is rotating. So because of that, obviously whatever the material you are going to use, the metal, it is not like you cannot say the friction is zero. Every material obviously it will be having some amount of friction. So obviously because of that one there will be a losses in that impeller, and friction and eddy losses in the guide vanes or diffuser or casing. So obviously if you see all these points, whatever the different types of losses are happening, all these, whether it is the shocks and eddy loss, yeah, due to friction, see all these things, remember that hydraulic losses it's happened in the impeller or casing portion. ठीक है. There are other hydraulic losses. See, within hydraulic losses there is one A and one B. So other hydraulic losses is obviously that is friction at the in the suction pipe, and friction and other losses in the delivery pipe. So if you remember the diagram, suction pipe is there, impeller and casing is at what one location, and delivery pipe is there. So major losses will be hydraulic losses. Major hydraulic losses will be in the impeller and casing, and minor hydraulic losses will be happening in the suction pipe and the delivery pipe. Okay. So next, this is about the hydraulic losses. Now we will discuss about the mechanical losses. See, mechanical losses due to the disc friction between the impeller and the liquid which fills the clearance space between the impeller and casing. Yeah, losses pertaining to the friction of the main bearing and the glands. These losses are related to the like mechanical working of the instrument. So if the shaft is rotating at particular location, there is a contact between the water liquid which fills that particular space, all those things. So whatever the losses happens because of the working of the machine, all those things, those comes under mechanical loss. The last one is leakage loss. So obviously, whatever the instrument you are going to consider. It will be fitted by different component parts. So whether the leakage is in the casing or whether the leakage is in the suction pipe or leakage is in the delivery pipe. So because of that one, whatever there is a loss of energy because of those leakages, that type of loss is called as a leakage loss. Okay. So if you see this particular like flow chart or this particular diagram, uh, this somehow there is a shaft and the impeller. So between these two, that is shaft is rotating, because of that one impeller is rotating, there is a mechanical loss is going to happen in between these shaft and impeller. Uh, shaft will be sorry mechanical loss is going to happen, and between the impeller and output of the casing exit, that is delivery output, that means casing exit, that is nothing but the starting point of the delivery pipe. इन दोनों के बीच में there is a hydraulic loss is going to happen. I already told hydraulic loss happens in casing and the impeller portion. And obviously, other hydraulic losses will happen between the output to the delivery point. That means what we can say, other hydraulic losses means leakage, all those things in the delivery pipe under. Okay? So that is about the different types of losses. So till now, what we studied is we studied about the different types of heads, correct? Heads in the pump, and we discussed about the different types of the losses. Okay, losses in centrifugal pump. So next we are going to discuss the important thing, because numericals, whatever that you are going to in exam they will ask. Ultimately, the numericals will be based on the find the efficiency of the centrifugal pump. So there are different types of efficiencies are there. Okay? So let's see what are the different types of efficiency. Uh, Before going in detail, let's some formulas are there. We'll keep it very simple. So efficiency of centrifugal pump में पहले manometric efficiency आता है, ठीक है? Then mechanical efficiency आता है, and third one is volumetric efficiency आता है, and the fourth one is overall efficiency आता है. So these are the four types of efficiencies. Okay, let's see all these four. Okay, first one is monometric efficiency. Simple formulas hai. You remember those formulas and you can solve the numericals. Monometric efficiency is written as like this, which ranges from 60 to 90%. Okay. So formula for monometric efficiency can be written as monometric head divided by the head imparted by the impeller to the water. So obviously monometric efficiency is nothing but that, like efficiency is output by input, correct? So monometric head divided by head imparted by the impeller on the fluid or on the water. So monometric head कैसे लिखा है? H suffix m है, and you already know head imparted by the impeller to the water is VW2 into U2 divided by G. अगर G को ऊपर लेके गए तो it becomes G into HM divided by VW2 U2. So monometric head is equal to G into HM divided by VW2 into U2. You know already VW2 क्या है, U2 क्या है, HM, everything you know. ठीक है? Next, mechanical efficiency. See, mechanical efficiency is nothing but power at impeller divided by power at shaft. So what is power at impeller? So obviously that you know, W divided by G into VWT into U2, and power of shaft or power shaft power we need to calculate. Okay. So W by G can be written as rho Q, correct? So once again, these things are we already explained or we already discussed in the previous classes. So W by G into VW to U2. So instead of W by G, I can write rho into Q, because W is equal to rho into Q into G. Okay. So rho into Q into VW2 into U2 divided by shaft power. So that is your mechanical efficiency ka formula. Mechanical efficiency is equal to rho into Q into VW2 into U2 divided by shaft power. Okay. So this is shaft power, impeller power, output power. So between shaft and impeller power, this is mechanical efficiency, right? So between this impeller and output, this is monometric efficiency. Obviously, if you add all these things, you'll get overall efficiency. Okay? Then volumetric efficiency. So here you can write volumetric efficiency is equal to quantity of water delivered from pump per second.
divided by quantity of water passing per second from the impeller. So per second there. So obviously quantity of water delivered from pump per second is uh, Q, that is the discharge, divided by quantity of water passing per second from the impeller is nothing but Q plus delta Q. Okay? So where delta Q is the leakage of the liquid per second through casing. So that is your volumetric efficiency. Okay? The last one is overall efficiency. So overall efficiency consider किया तो output power of the pump divided by input power of the pump. Obviously, you are considering entire all types of efficiency मिला के overall efficiency find out करना है तो output power of the pump divided by input power of the pump. So what is the output power of the pump? Rho into G into Q into HM divided by input क्या है? It is nothing but shaft power. ठीक है? But you know HM, monometric efficiency का formula आपको पता है already. Monometric efficiency is equal to monometric efficiency, sorry, HM you know already, right? Monometric head is nothing but monometric efficiency VW2 U2 divided by G. You substitute in this equation. Instead of HM, you write monometric efficiency into VW2 U2 divided by G. So मैंने इधर लिखा. So rho into G into Q into monometric efficiency into VW2 divided into U2 divided by G into shaft power. Okay. So now if I remove that monometric efficiency outside, we'll get rho into G into Q into VW2 into U. Obviously G cancel हो गया. So monometric efficiency बाहर लेके आया हूँ. Rho into Q into VW2 into U2 divided by shaft power. But if you see this one, that is rho into Q into VW2 U2 divided by shaft power. So you go back, rho into Q into VW2 U2 divided by shaft power is nothing but mechanical efficiency. So you just write this is mechanical efficiency. So that means overall efficiency is nothing but monometric efficiency plus your mechanical efficiency. समझ में आया? So this is about overall efficiency. So these are the formulas, no derivation, direct these formulas याद रखो. So in the next class, we'll start with the numerical based on this centrifugal pumps, efficiency, work done, all those things. ठीक है? Hope आपको ये class समझ में आया. Let's see. In the next class, we'll solve some numericals. Thank you.